Alright, seems that we are live. Welcome everyone once again to another crash course, this time to be presented by Piotr Pasich. The course will be on how to write applications prepared for every cataclysm using Event Sourcing and CQRS. So without further ado, Piotr, the stage is yours. Thank you.
Okay, so hello and welcome. I really appreciate that you are watching this video. First of all, I will share my screen with and show you the presentation. Google Hangout, here it is. Now you should be able to see. Kuba, just confirm.
Sorry, 5 kilometers to the unmute button. Yep, we can see your screen.
Okay, so once again, hello. Today we are going to talk about this, how to heroize your application, how to prepare it for every single cataclysm, or at least for requests for change or a huge traffic on your website. My name is Piotr Pasich and I make for a living as a superhero at Xteam. Superhero Daily. So let's start. My story starts 5, maybe 7 years ago when I was working in a small company. We were hiring about 7 to 10 programmers, really great developers, but really unexperienced. And one day, a new customer came to our company and told us that he needed a solution for his problem. His problem was that he was selling items, and not only one item, not only one product, but 50 products. Not a big deal, you can think, but the deal was that he was going to advertise it, and there was a problem because he couldn't do that. Every other companies, every other e-commerce shops can advertise their shops or the products because they have it in on a single website, in one single place. Our customer had one product on one website, so every different product had on website, and it has until now, I think. So every single product, every single website should be advertised by different way. Different product needs different advertisement, and that was really huge deal for him. So he decided to ask us to create a new application, new service in the middle of the whole system, which will provide the content, so the banners, the links, the text, the articles, the videos, and everything else what can help advertising his products to deliver the content to the advertisers. When the advertisers will be able to put the piece of code, the images or the videos on their own websites, and when somebody will view the banner or click it, he will be redirected to our service, which will collect all information about the user and redirect it directly to the e-commerce shop. Basically, this system is called an affiliate system, and this works really similar to the Google AdWords. So you are able to download the JavaScript or the HTML code from our affiliate system, which is in the middle, put it into the website, and everything works fine. We can gather all information about the user. What happened then? User can order some product on the website, on the e-commerce shop, and you as an advertiser get your fee. And here's the problem for programmers and huge deal for the advertisers. The fee is enormously big. It's about 50 to 70%. So just imagine you have just put the banner on your website, nothing else, and for every single order for about $100, you get $70. You can just imagine how much problems can it bring to us as developers, because with huge money, huge money will bring huge traffic. But we, as a really unexperienced team, decided to move with this project and start developing, start coding. And I have to admit, I was one of the most experienced developer there. I was a team leader, with only 2 years of experience. That professional experience, that wasn't enough to finish this project in the due time, in the due date, before the deadline. But I think we did just a fine work with that. On the very beginning, we decided to stick to the technologies we know really well. So that was crazy time with PHP in the early 5 version, with the MySQL in the early 5 version, and then 1.1 or 1.09, as far as I remember. So nobody knows about the clean code, about the solid, about any other principles. Everything is really messy and really bounded to everything else. But still, it's one of the greatest projects I've ever worked in. We started as, and I bet every other developer will start with that, with drawing the first database draft. And as I said, we were working with the MySQL database, so this was really relational database. And I would like to present you a really small piece of the database, because this was the database had about 50 different tables dedicated for some other things, but the heart of our system was the event table. We were collecting all the information about the user, the type of advertisement, the IP of the user, the URL from the store where the advertise and where the ad was put, the timestamp, the browser, the country, the other information, basically all what we can get from the server variable in the PHP. So that was our heart of the database. If user viewed the banner, we put the information about that in the event table. If the user clicked the banner, we put the information about that into the event table. If the user ordered some things on the e-commerce shop, we put the information in the event table. In the biggest view, you can see that we related this table to the another one, to the user, which is our advertiser mostly. Of course, there were some administrators there. To the ad, this any information about that, what it is exactly, if it is an article, if it is an image, banner, video, or something like that. And of course, the ad is related to the product, because we need to know about what we are selling and where we should redirect the user. And in the product, we store the information about how much fee of every single selling, of every single order can we get to the advertiser, to the user. And there is a huge problem about this solution regarding to the fee, because the fee was so big. The users generated so much traffic that after the very first release, after going to the production and showing our product, our affiliate system to the advertisers, our server collapsed and went down, broke, and we had a huge black hole there. Why? Because we put everything into the event table. At the same time, 3,000 users try to get an information from the event table, because we provide banners and the content based on that what you have seen in the past, or where you have been, in our opinion, in the internet. So maybe you are interested in some product. So we need to get information about you from our event. If we haven't got any information, we put there. If you see any banner, if you view or click or order, we put then the information in the event. So the problem with MySQL and InnoDB engine is that you cannot do it really fast. You cannot handle 3,000 reads and writes per minute or per second, because it will crash. It will go down, and our server went down, even if it was really huge, about 256 processors with half a terabyte of RAM, and the disk storage in 2 terabytes or something like that. It was really fast server, but scaled vertically. And we are going to talk today about scaling horizontally the servers and how to deal with that. So after the very first crash, after the very first release on the production, my boss came to me and we had a really long discussion about the solution and how to solve that without increasing the cost of the servers. So we decided to basically split our database to the temporary event table, where we removed all the indexes, all the keys and primary keys, all the relations, and just stored the data there. We were writing just there, nowhere else but to the temporary event table. That was really fast because we changed the engine, of course, to the memory engine in MySQL. So that was really fast. Everything was stored directly into the memory. And every single minute or a half a minute, we were moving or copying the data from the temporary event to the event table, and that was our source of everything else. Then we were propagating the data from the event table to the reports. We decided to do that to decrease the cost of calculating everything, every single report, because the advertisers would like to see how the banners behave, if there are some orders about that, and every single information about that needs a new report. So we were basically propagating the data and collecting the data information from the event and copying it into a couple of report tables. But after all, we still keep the data, the information in the event. We don't remove anything. We don't update the event. We just store it and copy the data. And this is called event sourcing. The red part is red because it is not necessary in the event sourcing, but the event as a one place when you write the events, when you create an information about the behavior of the user or the application, and then propagate it to the report. This is called basically event sourcing, and I found it just 2 years ago, I think, with a really fine guy called Greg Young. I will introduce you in a couple of minutes. What is really important in this solution too is that we split it, the writes and reads from the database, to totally 2 different actions. So sorry about it. In the middle you can put not the event table but the queue, message queue, where which is really fast. Still I had no clue about this technology, about this idea about message queuing there. Those times, this is exactly why we created one another table, instead using a proper technologies to propagate the data. And I have admit the message queues, I love RabbitMQ, can handle a lot, about 20 billions of messages per minute. So it can handle almost everything. And what is really fine and interesting about this solution, we split it reads and writes to tables. You can write only to the temporary event and read only from the reports. If you have a user and you would like to show the banners or the content really related to something what he is interested into, then you need to create one another report table for the user or for the users directly and read from the reports. The only thing responsible or which can read from the temporary event is the message queue system, is the Rabbit or the event table or something like that, but you cannot read directly from the temporary event without anything else in the middle. In the CQRS world, it is split to the command and query. Command is responsible for writes and query is responsible for reads. The question is, and I know you are going to ask that, if you need two different tables for commands and for queries. The answer is not. Of course, you can read everything from, you can read and write to the one table, but in the code you split the responsibility there. And this is exactly why it is called Command-Query-Responsibility-Segregation. The previous version of this principle was called Command-Query-Segregation, but it was based only on the model. And Greg Young decided to expand this idea to the responsibility, so also for the code part of the application, not for only for the model, also for the business logic. But it brings us a lot of troubles during the development. Simply everywhere where you now have one class, one I don't know, a repository or one model, you need to create at least two classes, because one class is responsible for reading from the database, it is a query class, and one is responsible for writing to the database. It is a command class. So why do we do this? Why do we even use the CQRS if it is not dedicated for everything there? If we need to create two another classes, if we need to complicate the code. Well, as an agile team in the X team, we, or in every other company which is working in agile, you basically start with a really simple basic draft of the database schema, and it looks like that. If you need some new feature, in example, if you need to create a registration form for the user, you need to add one more table which is called user. If you need to create order mechanism, order functionality on your website, you need to create one another table. So with the orders, so the database schema is growing really fast with every single sprint, and it's growing and it's growing and it's growing, and at the very end you are finishing with something like this, which is really bounded to to one database, which may be MySQL, Postgres, MongoDB, or something like that. It doesn't matter. You have only one database, and everything is related to everything almost. And you cannot scale it horizontally really fast, because the only thing you can do is to copy the database to another database and grab the data from there, and you use the master database to write and the slave database to read. This is not a solution we are going to use, because some databases are really fine and really great in writing, and some other databases are really fine and really great in reading. And as an example, Elasticsearch. If you're going to implement the search bar in your website, then probably you should or could or may or going to use the Elasticsearch as an engine for searching the content on your website, but it's useless for storing the sessions. For the session, you can use some other database storage or something like that. In example, Redis. So you would like to really use the proper tools, proper technologies for the tasks, not keep everything in one database, because everything is going to crash, basically, as in our case. So the question is how to scale horizontally, not only to add new processors, new memory, or new hard drive to your server and pay more for the bills. The main idea is to understand the basics. This process is similar to the process how you learn the programming. You don't start with the code, with the syntax, how to develop things with the OPP, with the other things really related to the code. First of all, you need to understand the basics and the idea of programming. The idea, in example of making algorithm. If you make the T, most of the people will think about the algorithm like grab the mug, grab the tea, put the tea into the mug, and put the water there. It's not working like that, and I as a developer and you as a developer understand that. You need to define the object of the mug, of the cup, copy it to the variable, store the variable, and get another object, save it to the variable, and then set the and then put the one variable into the another one, put the one object into the another one. Then you can use the water. Then water is also some kind of the object saved in your data. There is such a difference between programmer thinking and as ordinary citizen thinking. So thinking about the CQRS, about event sourcing and all of the scanning idea starts in changing your think. That writing something to the database is quite different to the reading. It is not the same thing. And we need to say one more thing, that reading you always read more from the database than write to the database. You read about the statistics say that you read about the 90% of actions made on the database is reading, and 10% of actions made on the database is writing. So you scale it totally differently. You should scale the reading, and it is exactly why people create the cache system for the reading. You don't scale the writing because it's not necessary to do it in modern systems, because it is only a half of a problem. You scale only the reading machine, and most of people are creating the cache system. How the cache system works? It downloads the proper data from the database, calculate it, moderate, creating some proper objects, and save to the file, to the memory, to some other database. And I would say you that the very first user which will read the data read the information from the database will wait a long of time for generating the cache. The second is unnecessary. He will get the data directly from the cache, so it will be really fast. So what if I tell you that we can move this cache to the writing machine? So you can ask if the writing action won't take such a long time. This is exactly why we put the message queue there. The user who is going to write to the database and user who is going to read from the database are not going to wait for the message. The message queue is going to handle everything what is in the middle, and takes more than a couple of milliseconds. And in the CQRS world, we call it quite differently. We have own language for that. The writes are the commands and the reads are the queries. There might be some problem in the frameworks like Symfony, because the command as a word is dedicated for something really else, but you can of course change the name or put the command files in another directories. So the meat, the code architecture, how to start with it. So let's start from the very beginning, how the most of application looks right now. You have from the left side, you have the user interface, which is basically the JavaScript, mostly the JavaScript and HTML code. Business logic in the middle. This can be created in the React, in the JavaScript, or in the PHP, even in the Java or C#. You have some layer to communicate with your database. In most cases, it is the ORM system which is mapping the database structure to the objects and delivering to the business logic. First thing to do to achieve the CQRS is to split the business logic to command and query part or the writing and reading part. This can be put in the same application. This can be put into different applications. If you have really a bottleneck in your application which needs to write fast to your model, obviously you would like to avoid to use some really complex and complicated things like ORMs and something like that. You would like to just put the information to the database, like in our case in the past with the events. Storing the views was a really huge achievement because we was able to handle about 3,000 views per second from the client side, and this solution requires us to create one another system, one another application to handle just the views from the database, and we avoided to use any other system like ORM, Doctrine, or Propel. We based our code only on SQL statements, and the reads was responsible for delivering the reports. The very next step is splitting the model for two parts: one responsible for writing, one responsible for reading from the database. What is most important in this case, in the writing model, you cannot read, so you need to leave your thinking about the IDs somewhere else because you know nothing about the IDs. In the Doctrine ORM system, you save the data, an example, save the data into the database and and you will have the ID updated into the object. So you basically put the data into the database and get the ID inside the object. It is not possible in the CQRS so simply. You need to be aware of that, what the ID will be after the saving to the database. It is fine because you can manipulate the data based on the ID. You can create some hashed IDs and so on and so on. This is a really huge advantage for you if the ID is generated by you in the business logic or the model layer done by the database, which is going just by the increased number 1, 2, 3, 4, 4,000. This will crash in a big data model. In our case, we needed to increase the number from the int to big int and then to the string of 20 numbers because the number of records was growing so fast. The database just went to the zero after 2 or 3 days with the small int ID saved into the database. But what is really, if you are going to prepare your application in this model with the writing model, and you really fine propagate your information, your data, and generate the reports from that, as in our application in the affiliate system, if you will move the data from the events table to the reports table, then the read model is not necessary. You can just get the data directly from the database without any model, without any ORM, without any queries, without anything, just simple SQL statements with listed the number of the rows, the number of the columns, and that's it. You just deliver it without any business logic, without any model, without anything in between, directly to the user interface. Because everything what you put from the right model, you process it, propagate it, calculate, and save to another database model. As another, I say you can write to the MySQL or the Postgres, then propagate it to another MySQL database, to the Elasticsearch, to the Redis, to MongoDB if you need. MongoDB is working really fine with the CQRS because you are not bounded to the database schema. You can save there whatever you want, and you can deliver whatever you want. So something like CouchDB or similar products are working really fine with preparing and processing the data for the reading model, because you're doing whatever you want with the data, and the database is responsible for that. You just create the views for the bucket. The writing model is responsible for putting the data into the bucket, and the database processes it to other views. So, and all the business logic is put to the writing model or the command business layer, and the cache system, the layer where you was going to put the cache system, is now into the in the databases infrastructure. So basically, that's the whole idea of that, and you can add as many database as you would like to, because those three boxes with the database are really well scalable in this example, because you can only and only add one another system to propagate the data, and it will work fine. So it scales really fast and works really fast in this scenario. Well, the meat of the meat, the code. We'll start with the PHP code. I'm the PHP programmer, but I really hope you will understand at least the idea of that what we were creating in this application. And we was starting with creating the really basics to understand everything. So we started with the interface of the command. This is empty because every single command is different in this system, but we would like to keep an information about that, which classes, which objects are responsible to be commands, and which classes are responsible are exactly the queries. So in the next slide we will have the same scenario, but with the queries. This really mirror, the query is really the mirror of the command infrastructure. So basically we have our command, which is responsible for storing the data. This will be delivered directly to the event or from the event table. Next thing which we were creating which we created is the command handler, which will be responsible for handling the commands, so preparing the data for our dispatcher and sending our data, our event saved event, to the dispatcher. And dispatcher is responsible for sending an information about our event directly to the external system, to save to the database, to send it to the message queue, and to propagate the data to another database. On the second place, we have the query interface, which is quite similar. We would like only to keep the information about that if the class is responsible to be a query or the command. And of course, the query dispatcher, which is there should be a query handler, which should be responsible for getting the information. What do you need from the database exactly? And the query dispatcher should be responsible for actually getting those information and returning it back. What is really important here, all the classes from the command interface, from the command part of the application, of the architecture, shouldn't return any value. It's just writing to the database, so you don't get any value. And the query part of the architecture don't write anything to the database, but returns the values. You can, of course, in the controller or in the business logic layer, use both of them. So in our case, in our scenario, in our application, we have created the class view event, which should implement the command interface. We have only one constructor where we put every single information about the user, like IP, like his country, his browser, his behavior, and then we have only and only getters. So we have really immutable object here, where you cannot change anything. As if you're going to change something inside this object, you really need to create one another object, because it is impossible to change anything, IP or the username or the browser or the country inside this object. This is really working fine with the event sourcing, because in the event sourcing you cannot change anything in the events. You can create to change the behavior in the events. You need to create a new event. In the example, just imagine the bank account. You have your history of the transactions, and if somebody paid you $1,000 in accident, because he was going to pay you only 500, you are not going to correct it. You are not going to say, oh, that's fine, and say update the amount of money, the cash to the 500, because this guy tells you to that. It brings you a lot of trouble after all. You will pay back $1,000 and create one another payment for 500, and then you have three different events in a list of events, but you know everything what's going on there. In our scenario, this was working that way. Every single month we were paying our advertisers some kind of money based on the fee they collected, and from time to time we discovered that there is some problems with, in example, calculating the fee. We had some problems with the money, but this was 3 months after the very first release and 2 months after the very first payment for the advertisers, so we were not able to change anything in those payments, because the bookkeeper would actually kill us for that, and we couldn't change the invoices for them. So we needed to recalculate everything from the event table, and we were able to do that. We had a full history of everything what was going on in the system, recalculate and check how much fee every single user need to be paid more than we paid in the past. And then we created new events called the fee recalculation or something like that, and added it to the system as an information. You as an advertiser were able to go to the system and see that there is a correction on your fee, and you know exactly what's going on there, that there was some problem in the system, but we fixed that, and now you get more fee for this month collected during last few months. This couldn't be possible if we created a system only storing the sum of the collected fee. We had a full information about that, and that was one of the most clever decisions we've ever made during this project, to collect every single information, store it, and don't delete. So the command handler is also really simple, because we put the information about the view event to the command handler, this creating an actual view object which can be propagated to the other systems. This creating the view event, because we are viewing this, and dispatching propagating everything to another services. Command handler can be quite different. Even dispatcher is almost always the same because it's just propagating the data to another databases or putting the event to the message queue. But the command handler can be dedicated for, in example, updating the information about the invoices, to adding the missing fee, to calculating some other things, because it's preparing the information for the other databases. And the other databases are storing this and deliver it to the users. This part is really important because if you are going to create a new feature, an example, new kind of report for the user, new kind of payment, new kind of the invoice, and you would like to not only show the report or the statistics from now when we broadcasted or published the new feature, but also show the statistics from the past, you are able to do that. You need to only to create a new type of the event and new type of the event handler, and that's all. You, after the very first release of a new feature, you are able to show for the customer full report or full statistics from the very beginning of the application. And I bet he will appreciate it. In a normal way, when you will just implement your application without event sourcing, without storing the information, you won't have such a great history of everything what's going on, what's happening in your application. Another scenario, if you are going to create a registration form, or if you are going to add an address to your user, you will, in the first place, you will create a piece of code similar to this. You need to create a user with the username and password, create an address, and set this address to the user, and it is fine in most of cases. But then you will set the fee. Set collected fee as 0 because the new user hasn't got any fee, and save it to the database. And if you would like to add some fee to the user, you'll do something like that. Add fee 12 get collected fee, and it will return fee 12. If the end users will all order some products after that, you just repeat this process and you just get the sum of the fee. So at the end of the month, it will be something about $1,000 or $3,000, but still you haven't got any history about it. You cannot say if this fee is collected fine, if this fee is calculated from this order or some another else. You just have a final sum of the fee, and this is not great. With the CQRS, with the event sourcing, connected with the event sourcing, you should create that with some another way. You should create another fee event where you put in information about the user who's responsible for the fee and the actual amount of money you would like to do, and send it to the event handler, which will execute the command and propagate the data to the another database and do the business logic, do all the magic. That's all, I think. To get the information, you just create the fee query, which will get the fee for your user, and that's all. If you would like to recalculate the fee, you just need to create one another event which will use the fee query for the user, which will get the fee, recalculate it, and create new events and propagate new events with the event handlers. So that's all for this part, for the part of the code. I have called this presentation that we will prepare you for any other changes and disaster. So I have one another and the last example for you how it works, the CQRS and the event sourcing with the changes, with something what is required from the client side. And just imagine that our system is working fine. It's collecting the information about the user, gathering it and propagating to the reports. We have at the very beginning only 4 reports in our system, but our customer decided to create 3 more reports. He would like to deliver something, some really new feature, some really great feature for his advertisers to work better with the advertise we are delivering. So we really need those 3 reports. And if in the normal way you cannot you publish the new feature and get the information and get all the statistics in the reports as null, as 0, because you have no if you will delete the data from the event table, then you cannot you haven't got any history of the behavior of the users. But in our case, when we keep all the information in the event table, then we can create new event, we can create new behavior, we can propagate that information, we can go through every single record from the past and generate the reports. So the reports in the date of delivering the new feature will have all the information, like the feature should be from the should be there in the application from the very beginning of the application live. And that's all. Thank you for watching this presentation. I hope you like it. Now is the time for Q&A, I think, if you have any questions. No questions. Okay.
Let's check on Slack. Maybe someone on Slack. Seems no questions. There is just one comment. That the course was really good. Yeah, man. I mean, you shared and just enormous amount of knowledge and experience with us. Thank you so much for that. I just feel like I've had a huge meal a moment ago for my brain. So yeah, once again, thank you, Piotr. Guys, if you enjoyed the video, please click the like button and write a warm word in the comments. And also, one more thing, next week Sven Berg-Rien will present another crash course on the changes in Drupal 8 for end users, clients, site builders, designers, teamers, and developers with focus on developers. So please join us once again next week. Thank you so much for coming.
Thank you.